If you want to learn about large language models in 2026, which is understand how these systems work, how to build with them, and how to stay relevant as this field evolves, this video is going to give you the exact learning paths that you need to follow step by step. I'm going to walk you through the courses that you should take, in what order, and most importantly, why each step matters before you move to the next one. Because honestly, there are hundreds of courses out there right now on LLMs. And if you're trying to figure out where to start, it can feel completely paralyzing. Should you jump straight into prompt engineering? Do you need to understand transformers first? What about fine tuning? What about agents? I totally get it. I have been fielding these questions constantly. So let me give you the clarity that you're looking for. There is a logical progression here, and once you see it, everything else makes so much sense. If you're new to my channel, hi there, I'm Ishwarya Srinivasan. I've spent over 10 years in machine learning and AI. I've got my master's in data science from Columbia University, and I've worked at companies like Microsoft, Google, and IBM building machine learning systems. Right now, I lead AI developer relations at Fireworks AI, which is one of the leading AI startups in inference space. So I've not only gone through this learning journey myself, but I also see every single day what skills actually matter when engineers are building real large language model applications. So let me share the paths that I would recommend. Before I give you the courses, I want to explain why the order matters so much. Because I see people make this mistake all the time. They jump straight into the shiny stuff. They want to build AI agents immediately, or they want to fine tune a model before they even understand what fine tuning actually does under the hood. And look, I understand the impulse. The applications are exciting. But here's what happens. You hit a wall. Something doesn't work and you have no idea why. At this point, you're just copying code from tutorials without understanding what it really means. And when you need to debug or adapt something for your own specific use case, you're just stuck. The learning path I'm going to give you builds on itself. Each step gives you the foundation that you need for the next step. Think of it like this. You're building a house. Foundations first, then framing, then the stuff that everybody actually sees. So if you skip the foundations, then the house falls. Alright, let's just get into it. Step 1 is fundamentals of machine learning and deep learning. And I know. You're here because you want to learn about large language models. Why am I starting with traditional machine learning? Here is why it matters. Large language models are deep learning models. They are built on the concepts of gradient descent, backpropagation, and neural network architectures, along with loss functions and optimization. If you don't understand these building blocks, everything that you learn later is going to feel like magic. And sure, the magic is fine for demos, but it's terrible for debugging and for making design decisions for actually building these things that work. You don't need to become an expert in traditional machine learning, and you don't need to spend 6 months here. But you need enough foundation that when somebody mentions a learning rate or talks about overfitting or explains why a certain architecture choice was made, you are not feeling lost. For this step, I recommend 2 resources. First, the machine learning specialization on deep learning AI, which is taught by Andrew Ng. This is the updated version of the famous Stanford course, and it is excellent. It covers supervised learning, unsupervised learning, and practical aspects of building ML systems. It is thorough but accessible, and Andrew has a gift for making complex topics feel very approachable. Second, once you have got those basics, go through MIT's Introduction to Deep Learning course on introtodeeplearning.com. This is also a free course that covers neural nets, convolutional networks, recurrent networks, and importantly, starts to touch on the sequence modeling concepts that leads directly into transformers. The lectures are very well produced and the code labs are very practical. So here is my advice for this step. Don't just watch the videos, actually do the exercises. Build the small projects. The goal isn't to memorize the formulas, it is to develop intuition for how these systems learn and why they fail. That intuition will serve you for the rest of your career, trust me on that. The common mistake that I see is people rush through this step because they are eager to get into LLMs. Then 2 months later, they are trying to fine tune a model and they don't understand why their loss isn't decreasing or why their model is overfitting. So take your time here. A few weeks of solid foundation work saves you months of confusion later. Then step 2 is where you get into the architecture that powers all of the modern language AI, which is transformers and attention mechanism. This is the most important technical concept that you learn in this entire journey. Every major LLM, whether it is GPTs, Claude or Llamas, Mistrals, whatever, they are all based on the transformer architecture. If you understand transformers deeply, You understand the engine that's driving this entire Gen AI revolution. So the key innovation here is something called as self-attention. And the basic idea is this. When the model is processing a sequence of text, attention allows each word to look at every other word and figure out which ones are the most relevant for understanding the current context. This is what allows these models to capture long-range dependencies and understand nuanced relationships in text. For learning transformers, I have two resources that I think work incredibly well together. The first is Jay Alamar's Illustrated Transformer blog post. This is legendary in the machine learning education world, and for a good reason. Jay takes the original transformer paper, which is dense and mathematical, and turns it into something which is visual and intuitive. He walks you through the architecture piece by piece with beautiful illustrations. I still go back to this post when I need to explain attention to somebody, so definitely bookmark it. Read it carefully and read it more than once. The second resource is Hugging Face's LLM course, which is specifically starting with the NLP fundamentals. Hugging Face has put together an incredible free course that takes you from transformer basics all the way through working all of these models in code. What I love about this course is that it's all hands-on from the start. You are not just learning theory, you're actually using Hugging Face library to actually load models, run inference, and see how everything works in practice. Here is what I want you to focus on in this step. Really understand attention. Understand what queries, keys, and values are. Understand how attention weights are computed and what they represent. Understand multi-head attention and why having multiple attention head really helps. And understand positional encoding. Once you have this down, reading papers becomes so much easier. You start to understand why certain design choices are made. You can follow along when new architectures are announced and understand what's actually novel about them. One thing I'll add, try implementing a simple transformer from scratch at some point. I'm not asking you to build something like GPT-4. But coding up the attention mechanism yourself, even in a most simplified manner, will cement your understanding in a way that reading will never do. Step 3, pre-training, fine-tuning, and retrieval augmented generation. These are the three main ways LLMs get created and customized for specific applications. So let me break down each of them for you. Pre-training is the initial training of a foundational model on massive amounts of text. This is where the model learns language, facts, reasoning patterns, everything that makes it capable. Most of us aren't going to pre-train our own model from scratch because it requires enormous compute, resources, as well as data. But understanding how pre-training works helps you to understand what these models know, what they don't know, and why they behave the way they do. Then fine-tuning is taking a pre-trained model and adapting it for a specific task or domain. Maybe you want it to respond in a certain style, or you want it to essentially be good for medical questions, or you want it to allow to follow specific instructions or output formats consistently. Fine-tuning adjusts the model's weights using specific dataset. Now, there are different kinds of fine-tuning for large language models, which you'll see deeper in the course. Then RAG. Retrieval augmented generation is a different approach where instead of changing the model's weight, you give it access to external knowledge at inference time. The model retrieves relevant documents and uses them to inform its responses. This is huge in enterprise applications because you can give an LLM access to your company's private data without having to fine-tune the model. So for the resources in this step, I have got several that I think are essential. First, Cohere's LLM University is fantastic. It is free, it is comprehensive, and it covers the practical aspects of working with large language models really well. They cover embeddings, retrieval, prompt engineering, and fine-tuning in a way that's immediately applicable. For pre-training specifically, Deep Learning AI has a short course called Pre-Training LLM that gives you a solid conceptual understanding of how these models are built from scratch. You'll learn about data preparation, training objectives, and the decision that goes into creating a foundational model. Even if you never pre-train your own model, this knowledge helps you to understand the capabilities and limitations of models that you're using. Now, for fine-tuning, there's another Deep Learning AI short course specifically on fine-tuning large language models. This is more hands-on and covers the practical techniques you'll actually use, including parameter-efficient methods like LoRa that lets you fine-tune with much less compute than traditional approaches. Now, here is a practical tip for you. You don't always need to fine-tune. I see people jump into fine-tuning as their very first solution when often prompt engineering or RAG would solve the problem more efficiently. Fine-tuning is powerful, but it has costs. Compute compute costs, data preparation costs, and ongoing maintenance as you need to retrain it. Understand all of your options so you can pick the right approach for each situation. And for RAG, I would highly recommend building something after going through these courses. The Hugging Face course touches retrieval, and you can use what you learned in the step 2 combined with the concepts here to build a simple RAG system. That hands-on experience, I'm telling you, is invaluable. Now, step 4 is where everything comes together. Building applications and working with AI agents. This is the frontier right now. AI agents are systems that can take actions, use tools, and accomplish complex tasks with some degree of autonomy. They're what everyone's excited about in 2026, and for a good reason. They represent a shift from large language models as chat interfaces to large language models as components in larger systems that can actually do things in the world. 2025 was definitely a kick into the agentic AI system. But here is what I want you to understand. Agents are hard to get right. They are powerful, but they are also very unpredictable. They can fail in subtle ways. They need careful design around what they are allowed to do, how they handle errors, and how they explain their reasoning. All the fundamentals that you've built in the steps 1, 2, 3 becomes critical here. For this step, I've got 4 resources that approach agents from different angles, and I would recommend going through multiple of them because they each offer something different. So first is the Hugging Face Agents course. This is a great starting point that covers the fundamentals of what agents are, how to build them using popular frameworks, and practical considerations for making them work reliably. It is free and it's well structured. Second, if you want to go deep on the research and advanced concepts, Berkeley's Large Language Model Agents course is incredible. This is an academic course that brings speakers from all of the top AI labs talk about their cutting edge agent architectures, reasoning, planning, and the theoretical foundations. It's more advanced, but it'll give you an insight into where the field is headed. Third, Arise AI has a course called AI Agents Mastery that focuses heavily on the operational side, how to evaluate agents, how to monitor them in production, and how to debug when things go wrong. This is the practical production knowledge that does not always get covered in other courses. And fourth, Deep Learning AI has a course on multi-agent AI systems. This focuses specifically on building systems where multiple agents work together, each with different specializations. It's a pattern that's becoming increasingly common for complex applications. My recommendation is that don't just take courses on agents, build something. Pick a problem that you really care about and try to solve it with an agent. Maybe it is automating part of your workflow, maybe it is building a research assistant, maybe it's creating a tool that helps you with a hobby. The learning really accelerates when you're trying to make something work for real. Here is a common pitfall that people make. People give agents too much autonomy too quickly. So start with a very constrained agent that has limited tools and clear guardrails. Get those working reliably first. Then gradually expand what they can do as you build confidence and understanding of these agents. Well, that's the path. It's not the fastest, but it's the path that will actually work. The one that gives you lasting understanding rather than just surface level familiarity. All the courses, all the blog posts, everything that is there waiting for you. So go grab them. And if this was helpful, please hit that subscribe button and turn on the notification bell. I post regularly about AI and ML career advice, free learning resources like these, technical explainers, and my journey as an immigrant in the US building a career as an AI leader. I try to share all the things I wish somebody had told me earlier. And I would love to hear from you in the comments. Where are you in this learning journey? Are you just getting started, or are you already deep into agents and applications? What's the hardest part for you? Let me know, and also let me know what topics you would like me to cover next.